consider a new data set, the first thing we do is to graph the data and look for a pattern. Once we do this, the next step is to describe the center and variability. After this, we want to describe the distribution with a smooth curve. This is known as a density curve. And the idea is that we can use this density curve to then answer questions about proportions. Here we can see a histogram with a density curve. And density curves are going to have a couple of overall properties. First, a density curve will always be on or above the x-axis. Next, the area between the density curve and the x-axis will always be 1. This curve is used to describe the overall pattern of the distribution, and the area under the curve represents proportions of the population. And while this density curve that I have here is symmetric, we can have density curves that are skewed left, skewed right, bimodal, uniform, and lots of other shapes. And if there's a question about a proportion for the given density curve, our first step is going to be to shade the area in the curve that we're referring to, and then we want to find the area of the shaded region. So area and proportion are going to be interchangeable for density curves. Let's start by looking at a uniform curve. This curve here represents a 4-mile stretch of road where accidents occur uniformly along the road. We can see that the length of the rectangle is 4, since there are 4 along the bottom. And since the area always must be 1, then we can tell our height is 1/4, or 0.25. Let's suppose we want to know what proportion of accidents occur between 0 and 2 miles. I'm going to go ahead and put a vertical line at 2 and shade the region between 0 and 2. And this is a rectangle, so I just need to find the area of that rectangle. The length across the bottom is 2, and the height is 1/4. So when I multiply these, I get 0.5 or 50%. So approximately 50% of the accidents that occur on this stretch of road will occur between 0 and 2 miles. Let's look at one more. What proportion of accidents occur between 0.5 and 1.2 miles? So this time 0.5 about right there, and 1.2 we'll say is about right here. We're going to shade between there. This is still a rectangle, but it's a little bit more work to figure out the width. So this width occurs between 0.5 and 1.2. So if I subtract 1.2 minus 0.5, I get 0.7. And that is going to be the width of this rectangle. Its height is still 1/4, and if I multiply these, I get 0.175, or 17.5%. So approximately 17.5% of accidents will occur between 0.5 and 1.2 miles of this road.
If you would like to see Professor Pierce make more videos like this one, you can support her on Patreon in the link below. Any and all support means a lot to her. It allows her not only to make more videos, but it also allows her to campaign for free and accessible online education to conferences and other universities. Thank you for watching, and remember, math is for everyone.